here. Okay, so anyway, so acids are defined as any hydrogen salt that dissolves in water. It's an aqueous state always, so we use the AQ, and we call it a hydrogen with an anion. Okay, so now comes this flow chart. This is where you can say yes. Is the cation hydrogen? And you can now say yes, it is. Okay? So, first question, if you say yes, is it aqueous? An aqueous acid is different than a solid acid, how you name them. Solid acids don't have the term acid on them. They're just a hydrogen something. Okay? So, for example, if you look over here, if I have HF, just being HF, we would name this. How does it say to name it if it's not dissolved in water? What does it say? She's named the cation, which is hydrogen. And what is F?
Just name it.
Just fluoride. Now, if you were happen to say hydrogen monofluoride, I'd let that go. That's what we've kind of taught you to do. But really, you don't use prefixes when hydrogen's present. Okay? I just didn't want to go into that with you when we did type 3s. But you just name it hydrogen fluoride. That's all it is. But as soon as we put that aqueous behind it, it changes things. HF aqueous now makes this an acid. What's it say to do? It says, is it aqueous? Yes. Is there oxygen present is my next question.
No.
There's no oxygen present in this compound. So, you put the prefix hydro. And what's the root of the word fluorine? Fluor. Rick. This is hydrofluoric acid.
I've heard that before.
Yes. HF is just hydrofluoric acid. Does that make sense? Okay? So, if there is not oxygen, you put the hydro. Here's what I was saying. If it doesn't have oxygen, little hydro, you got the O there. Does that make sense? So if there is no oxygen, hydro. O, oxygen, hydro. Get it? It helps, okay? Let's try a couple more.
What if there is oxygen?
Well, then you name it a different way. We'll get to that in just 1 second. So if I say H3N. So H3N is hydrogen. Look. Aqueous. Is hydrogen my cation? Yes. Is it? Let's move this over here so you can see us. Okay. So it's hydrogen's present. Is it aqueous?
Yes.
Yes, it is aqueous. And is there oxygen present?
No.
No. If oxygen is not present, what's the first thing you write down? Hydro. Good. Hydro. And what's the root of nitrogen? Nitro. Rick. Acid. So you put hydro, the root of the word, ic, acid. Now you're going to take a little time to get used to some of these, yes.
What if it's arsenic?
Arsenic.
Like hydrogen?
Probably hydroarsenic acid, I would think. I don't think it makes an acid. But that's a good question. I don't know. So I'll have to look that one up. Look at him. Thinking. Okay, does that make sense? Yes? So if I have this, so if I have, how would I write a formula for hydrosulfuric acid? So H, hydrogen has what kind of charge? +1. Sulfur has what charge?
Negative.
So that 2 comes down here, that 1 comes over here, and we get rid of, so H2S, aqueous. Does that make sense? Straightforward. Okay? Now, what if it has oxygen? So, let's do one with the oxygen. So if I have HNO3 aqueous. So, is hydrogen my cation? Yes. Is it aqueous? Yes. Is oxygen present? Yes. When oxygen is present, it means that there is a polyatomic there somewhere. Okay? So what's my polyatomic in this compound? Nitrate. NO3 is nitrate. Correct? Good. If the ending is ATE, we change it to ick. Ick, I can't believe I ate the whole thing. You want to remember that way. Okay? Ick, I can't believe I ate the whole thing. And if it's ite, it goes to us. Make sense? So this is going to become we're going to get rid of the ATE, and it's going to be nitric acid. Do not use hydro, because the O is already there, so we don't need to use hydro. That makes sense? So far, so good? Okay, let's do another one. Let's make sure. Okay. H2C2O4 aqueous. Is hydrogen my cation? Yep. Is it aqueous? Yep. Is oxygen present? Yep. So what is my polyatomic in here? Oxalate. Oxalate. So I get rid of the ATE and put what? Oxalic. Yep. Oxalic acid. Make sense? Yes, sir.
What happens if it's not a octave and it's like octave, but it's not like that?
Oh, then it would just be hydrogen oxalate. If this aqueous was not there, we just name it as we see it, hydrogen oxalate. That'd be it. Does that make sense? And if you go the other way, so let's say you have, I think, chromic acid. So, first element's going to be H because it's an acid. We know that, right? What's chromic come from? Fifth, yeah, because this was chromate, right? So CrO4 with what charge? -2. Crisscross your charges. That 2 comes down here. That 1 comes over here. And it's H2CrO4. Sorry, aqueous. Eventually, I'm just going to tell you they're always going to be acids, so, because I do forget to write that. How are we doing, okay? So what we're going to do, I'm going to give you some time to practice some acids, and then what I want you to do is, once you get done with that, show me your paper, and I'll give you tonight's homework, which is a mixture of all of them. Type 1, type 2, type 3, binary, polyatomic, and acids. All mixed up. So you're going to have to figure your way through all those. Uh-oh. Got it?